Okay, today I'm going to take a look at some GCSE physics, static and current electricity and Ohm's law questions. The first question comes from June 06, paper 1, and we're asked to draw a circuit diagram using the correct symbols to investigate how the current flowing in a metal wire depends on the voltage across the wire. This is the standard circuit that is required for any of these investigations, and we need to have a battery with a variable resistor in series, and that allows us to change the current. We then need to measure the current, so we have an ammeter in series with the component, and this time the component is a wire, so we simply draw on our wire like so. And we need a switch in the circuit so we can switch it on and off. We'll come back to that later. And then the last thing that we need to do is we need to measure the PD across. So we put a voltmeter across the component in parallel. So we have the five components. We have variable resistor and battery, and that allows us to change the current and PD readings. We have the ammeter to measure the current. We have the component, and we have the switch, and we have the voltmeter across to measure the PD. The next part of the question asks, describe what Anne should do to get a series of readings. And very simply, she should change the variable resistor to get a series of current and PD readings or voltage readings. What must Anne do to ensure the temperature of the wire does not change during the investigation? Well, in order for the wire not to heat up, you need to switch the circuit off whenever it's not been used, and only switch it on when readings are being taken. So switch the circuit off. When readings are not being made. Okay, the next part of this question then goes on to take a look at resistors connected in series. And here we can see the circuit diagram with the 2 ohm resistor and a 6 ohm resistor connected in series, 12 volt battery providing the electricity. First of all, we're asked the total resistance of the circuit, and that's fairly straightforward. For resistors in series, the total resistance is going to be equal to R1 plus R2, which in this case is just equal to 2 plus 6, which is equal to 8 ohms. So the total resistance is equal to 8 ohms. We're now looking for the current that is flowing in the 2 ohm resistor. So the current that flows in the 2 ohm resistor, because this is in series, the same current flows through the 2 ohm resistor and flows all the way around there. So we work out the current flowing using V equals IR, and this time we're going to use the total voltage, so that means that 12 is equal to the current times the total resistance is R, which is 8. Therefore the current is equal to 12 over 8. That means that the total current then is equal to 12 divided by 8, which is equal to 1.5 amps. So the current flowing in both the 2 ohm resistor is 1.5 and in the 6 ohm resistor is 1.5. Now we're asked to calculate the voltage across the 2 ohm resistor. So we're looking for the voltage now across this 2 ohm resistor, and we're going to use then the same equation, V equals IR, but this time we've got a resistance of 2 ohms. The current that goes through it is still 1.5, so we can work out the voltage using V equals IR. So we simply say V equals IR, therefore V is equal to the current is 1.5 times 2, which is equal to 3 volts. So the voltage across that is 3 volts. That would mean that there would be 9 volts across the 6 ohm resistor to give us 12 volts total. Okay, now